pass edge or neg edge events. So if a vector is to be used, then specify which bit is to be used for the edge detect trigger. Okay, so the code above could be written as always at pass edge of address 15. Okay, so trigger to change on the MSB of the vector. So this is what they're trying to say. You can avoid this thing only by writing one bit. Okay, because it is a transition in one bit only. It will wait for one bit, not vector. So the operation in sensitivity list. Okay, so the operation in sensitivity list. So operation in the sensitivity list only trigger on the changes to an operation result. So whenever there is a change in this result, then only this will execute. Okay, always at A or B, gocha, this is an operator, not a separator. Okay, so OR is a separator, not OR. So if you're using OR, okay, so this is a separator, not an operator, but this is an operator, not a separator. Always at A and B, gocha, so this is a gocha. Okay, always at A equal to B, this is also a gocha. Okay, so they are trying to say these things. So when an operation is used in the sensitivity list, the add token will trigger on the change to result of the operation. Okay, so they are telling that whenever there is a change in the sensitivity list, the add token will trigger on the change to the result of the operation. So it will not trigger on the changes to the operands. So in the always at A or B example above, if A is 1 and B changes, the result of the operation or operation will not change and the procedural block will not trigger. Okay, so they are telling that this procedural block will not trigger. So why does Verilog allow this gocha? So what is the problem with this? So using expression in the sensitivity list can be useful for modeling concise verification monitors or high level bus function models. Okay, so it is strictly a behavioral coding style and it is one that is rarely used. So an example usage might be to trigger on a change to a true false test, such as always at address 1 or not of address 2. So the procedural block sensitivity list will trigger if the expression changes from false to true and vice versa. So this is what they are trying to say. Now how to avoid this gocha? Now what is the solution for this problem? Okay, so when modeling combination logic, the best way to avoid this type of problem is use always underscore comp or always underscore latch procedural block. Then only it will infer the correct sensitivity list, and which removes any possibility of typos or mistakes. So the Verilog at star can be used, but this has its own problems. Okay, so when modeling sequential logic, engineers need to be careful to avoid using operation within the sensitivity list. Okay, so this is the way we should avoid